Okay, let's start. And so, fine. So yesterday I think you have practiced and you have developed the two classes. I think there's one class called rectangle, right? There you could try all the various members which can go in a class definition. Fine. So we have seen about instance variables. Instance variable means fine, a separate copy for every object. Okay, it exists only with the object. If there is no object, there is no existence of instance variable. Fine. Then we saw about static variable. Fine, which has nothing to do with the object. Fine. So it is associated with the class definition. Fine. So one copy only for one class. Fine. It's associated with the class definition. Fine. Then we saw methods. Fine. Methods are nothing but interaction if there is an object. Okay. Only with the object you have a method. Fine. You invoke method on a target object. And then we also saw about static methods, and those are the ones they don't need any object. They are just like, you can think like they are the functions, and in C language we have functions, right? See, method means they have a target object. Static methods, they are like the functions, they don't have any object. You give all the parameters, it will do fine. It's fine. There's no object involved in this. Fine. When we have objects, target objects, fine, within those methods that target object is available on which the method is currently invoked with the help of keyword this. Fine. And then we also saw about constructors. Okay, so constructor, what is constructor? Fine. It's like the first method for a object. Fine, which will be used only once, and you don't invoke a method on an object. Fine, methods are invoked on objects. Constructor is not invoked on object. Rather, the object creation, when it is done, at that time invoke it. Fine, only at that time when you are creating the object. So the purpose is to give the initial state to the object. Fine, set up the instance variable. The instance variables define the state of an object. Fine. Okay, then we also saw about the two other things. There was a initializer block, and it's just like nothing but part of a constructor itself, right? Part of the constructor. And we also saw about a static block. Fine, static block, the purpose to initialize the static variables. Fine, you have static variables, you want some initialization, you can do it in the static block. It is executed before, as soon as the class is loaded. Fine, at the time of loading the class, it will be executed. So first thing executed will be a static block. Fine. Okay, so now and then yes, we had that exercise, right? So one exercise was the class rectangle where we had use of all this. Then another exercise was a class called account. Fine, so everyone could do that class. Okay, fine, and there was one modification to that class account. There was one modification in that exercise. Yeah, so that was also achieved. Fine, you had to use a static variable to manage the last given account number. Fine. Okay, so now let's proceed with the next topic. Fine. So today we'll discuss about inheritance. Fine. Inheritance from a class, and how to create a subclass of an existing class. Fine. To create a subclass of an existing class, yes, what do we do? Okay, so here we already have one class. Let's try to create a subclass of our existing class. The class which we have currently is the class called rectangle. Okay, fine, rectangles have length and width. Okay, now let's go for a subclass of rectangle. Fine, so someone says fine, we have a cuboid as having length, width and also a height. Okay, so we can go for a subclass here. Fine. Okay, should we go for a subclass? Because we have an additional variable? No, that's not a reason for going for a subclass. Anyway, fine, for this exercise, fine, let's take that exercise once. Fine, it's wrong, right? Okay, it's not the correct inheritance. Fine, we understand that, but still let's go ahead with this, and then later what we'll do is we'll see what is the actual way of doing it. Fine, it shouldn't be inheritance, that's one thing, but let's do it with inheritance. We want to have a class called cuboid. Okay, so in order to have a class cuboid as a subclass of a existing class called rectangle, fine, let's try and proceed with the definitions. So we'll have a class called cuboid, okay, fine, which would extend. So we use the keyword extends. The keyword extends is used for inheriting. Fine, inherit from my existing class is rectangle. Okay, so inherit from my existing class called rectangle. So that's extends keyword. And use extends to specify that yes, I would like to inherit from rectangle. Fine. So maybe someone has just this version of the class. So what happens here? Yeah. The class cuboid would inherit from rectangle. What does it inherit? Methods, fine, and instance variables. Fine. Static variables, they are not said to be inherited. Static methods, no, they are not said to be inherited. See, inheritance relates to objects. Right. So anything which is related to object, yes, that's going to be inherited. Fine. Two things get inherited here: methods and methods and instance variables. Fine. Okay. So what it would mean is, yes, if you have a variable of type cuboid, fine. If you have a variable of type cuboid, I should be able to do exactly whatever I can do with rectangle. Okay. Fine. Later we'll see there is some problem with this. Fine. This definition would not compile. We'll come to that. We'll see why it shouldn't compile. Okay. So fine, but keep that in mind. Okay. For us, yes, currently our knowledge says okay. Cuboid inherits from rectangle, and here, yeah, this should be okay. Fine. Now let's make some changes and let's add more things into the cuboid class. Fine. It is inheriting variables. Fine. Length and width from rectangle, and we are interested in adding one more variable here. Fine. We'll say okay, let's add a height also. So we'll say okay, it also, so we add one more instance variable called height. Fine. So what are the instance, how many instance variables do we have for cuboid? There are going to be 3 instance variables. Okay. Fine. So we add a additional instance variable. Let's add a method also now. Okay. So let's have a method called volume. Fine. Cuboid will have volume. So we want an integer. Fine. Return type is integer. We have the name as volume. Fine. Parameters for volume. Nothing. Fine. On a cuboid object, say what's your volume, right? So we don't have to pass a parameter to volume method. Yeah. What's the code for volume? You already have inherited the method called area. Okay. So what can we write? Return. Okay. So we have said this dot area into this dot height. Okay, fine. So this looks okay. Fine. Fine. Compute the volume as area on the current object multiplied by the height of the current object. Fine. So that anyway is for the volume. Okay. Next, let's try to write some constructor. Fine. Now let's look at constructor. Fine. So we want to have constructor. So how many parameters would be needed to create a cuboid? Fine. If someone wants to create a cuboid, how many input will you take? 3. Okay. So we have a constructor for cuboid requires 3 inputs. A int for the length, another int for the width, and another int for the height. Yeah, and what goes in this? Yeah, in this constructor, what is it that we'd like to do? Initialize the instance variables related to rectangle also. And we know we have the constructor rectangle which can do the initialization related to the rectangle. Okay, for that we have a different keyword. No, we don't use this. Okay, we don't use this because constructor is not inherited. Constructor is not inherited. Instance variables and methods, only those two are inherited. Constructor is not inherited. This current class does not have a constructor with 2 parameters. This one doesn't have. It's only the superclass of this class which has the constructor with 2 parameters. So what you would like to do initially is you would like to invoke the constructor of superclass. Fine, you would like to invoke the constructor of superclass from the constructor here, and that can be done by using the keyword super. Use keyword super and invoke the constructor. So fine, we can pass the length and width over here. Fine, and of course then you might be saying this dot height equals height. Something like this may be done later. Fine. Okay, so we have the use of keyword super. What's the use of super? Invoking constructor of superclass can be used only from a constructor. Fine, the super represents is nothing but invoking constructor of superclass. So there must be some existing constructor of superclass which takes 2 integers in this case. Okay, now another point, just like we could use this to invoke the constructor same class, but if we use this, it has to be the first statement of the constructor. Same way, in a constructor, if we use super, it has to be the first statement in the constructor. If we use super, it has to be the first statement of the constructor. Okay. Now another statement which we have. Okay, so mark this statement which I am making next. In any constructor, and for any constructor, the first statement is either this or super. The first statement of any constructor is either this or super. If you don't use this or super, and if you don't use this or super as the first statement in the constructor, fine, the compiler would assume, super without parameter as the first statement in the constructor. And the idea is, fine, if you are creating any object, fine, if you are creating object of any class, fine, it would include the object of the superclass, everything related to the superclass. So initialization of that superclass things must be finished first. Then you go ahead and give the initialization related to your current class. Fine. So constructor says yes, always if you create any object of a particular class, the constructor of its superclass will be used first. Okay, it first finishes with the construction of initialization related to superclass, then your constructor code will then be executed. Rest of the code can then be executed. And so always if you call any constructor, its superclass constructor is definitely used. Fine. Even if I'm not using super, suppose I don't use super, what would happen? It would use super without parameter. So what should happen now? Error. It's an error, right? For this particular class cuboid, if I don't use super explicitly, then it would be a compilation error, because it would try to use super without parameter, which is a compilation error. Fine. Now you know why that first one is an error. A class definition for cuboid where I just say extends rectangle and just end the class there itself. What would happen if I write the class cuboid extends rectangle and don't put anything at all in this? What would happen? Every class has a constructor. If you don't put a constructor, the compiler will try putting one. So what will happen? Which one? Constructor without parameter, and from there it says super. I don't have a no argument constructor. Fine. So if your super class does not have a no argument constructor available, fine, you are forced to have at least one constructor explicitly mentioning super. Fine, at least one constructor in a class which says super. Fine, how it is being forced? Clear? Okay. Fine. So constructor part, use of super to invoke the constructor of super class. Fine, that should be okay now. Fine. Now the next thing is we have a method. Fine, we have the method. We have inherited a method called area. Okay. So area for rectangle is length into width. But let's say we have cuboid, which is a kind of rectangle, because we have said it extends rectangle. May not sound good, right? Cuboid is a rectangle. Doesn't sound good, right? Okay, fine. Anyway, but we have made that statement once we say it extends rectangle. Fine. Extends rectangle is saying, oh, cuboid is a rectangle. Fine. That's what it means. Okay. But now having said that, let's see. So we are saying, okay, it's a rectangle, but in this case, there's a special case kind of a rectangle where area is calculated as length into height. Suppose that's the case. Fine. Exception to the rule. This is nothing but overriding. Fine. So let's try overriding the area method. So we go ahead with overriding the area method. And the way we override the area method would be, okay, the area method return type is int, name of the method is area. Fine, does not require parameter. And this matches my method signature as available in superclass. So this is a overriding method. Fine, that's a method overriding. Fine, and what do we do here? Oh, we'll say return, yeah, this dot length into this dot height. Okay, so we have this kind of a area calculation. And that's our method overriding, and we got the area method. Fine. And now someone goes for and writes a main method, let's say. And with this definition, let's say someone goes for a main method. Okay, you can add a constructor also, overload the constructor if you like. So someone wants to overload the constructor and says, okay, constructor for cuboid which takes single parameter, that is the side. Okay, overloading is done. And what do we do here? You can use this. And so first statement is either this or super in a constructor. And you can use this to match. The invocation should match a constructor of the existing class and the current class. Super, that invocation matches a constructor in super class. Okay, now someone writes a main method. So I'm just writing a part of the main method. Now he says, he declares variables like this. He says, oh, we got rectangle R1, R2. Okay, and we got cuboid C1, C2. Fine, we got these declarations, and then let's have some initialization of these. Let's have creation of the objects. The objects being created are something like this. He says R1 equals new rectangle of 7 by 5. Okay, R2 equals new cuboid of 7 by 5 by 4. Okay, C1 equals new, let's try rectangle of 7 by 5, and C2 equals new cuboid again of 7 by 5 by 4. Yeah, what happens if we compile this? Error. Which one?
Second, third one. Second, third one.
Which is superclass? Which is subclass?
Rectangle is super.
What is assignable?
Parent which I assigned.
Subclass object can be assigned to a superclass type. And the error is in the third one. Okay, so fine. So we can't have this one, right? Okay, that's going to be a compilation error. Fine. It's mainly the problem because of is-a. Is-a, right? Okay. Now, the next step is, so we have these three statements, and now someone says, what is R1 dot area? What is R2 dot area and what is C2 dot area?
The first two segments.
First statement is R1 dot area, so that's going to be
Rectangular area.
so 7 by 5. What is C2 dot area? 7 by 4. Problem is about R2. What is the R2's area?
Rectangle. Rectangle span. Cuboid. Rectangle span.
You got an object of cuboid. And say you have a variable for vehicle, right? And there's a place for a vehicle. You kept a scooter there and you say start. What is going to be started? It goes by object. And it's not by type. Fine. What method to use is not decided by the type. It will be decided by the object. What is the object available at runtime? Fine. It is the object of cuboid. So for R2, the calculation is according to cuboid and not according to rectangle. We call this as late binding, or we say method binding in Java is done at runtime. It's not decided by the compiler. Fine. What method to use is not decided by compiler. At the time of compilation, data type checking would be done. Fine. According to the types, everything is okay or not. It knows only the type. It is not executing the code to know which object it is. Fine. Object creation takes place when you run. Okay. So fine, in Java, method binding is done at runtime. What method to use, fine, which implementation of the method will be used is decided only at runtime. So at runtime you have objects. So it is decided based on the object which you have. Fine. So in this case, yeah.
So, but if you cannot override the area method, then obviously the current method will be good.
Okay. We got two classes. One class is rectangle. We have the subclass called cuboid. Both of them have a different version of area. Fine. So which area to use? Decided by object. Fine. It's not decided by R2 is declared as rectangle. No, it doesn't matter to me. Fine. It's not going to decide that which area will be used.
But if we are not override the area object,
If we did not override the area method, fine, then even for C2 it would be the same answer. Fine. So for all three then it should be same. Fine. So method binding, the clear point here is method binding is done at runtime, fine, and not at compile time. Okay, and later we'll see about another point, which is variable binding is done at compile time itself, and we'll come across that. We'll see what is that case. But method binding is at runtime. So methods, which method to use is decided by the type, the object, and not by the data type. Okay, now next question. What is C2 dot volume? And what is R2 dot volume? What is C2 dot volume? Fine. What's the area method which is available to cuboid? We have written volume as area into height, and area, because of overriding, has become length into height. Okay. What about R2 dot volume? Why 7 into 5 into 4? It's an error. It's a compile time error. Fine. See, for compiler only knows the type. What is R2? R2, what is the data type? This is compiler looking at the code, right? So compiler says this is R2. R2 is type rectangle. Rectangle has volume, but it doesn't have volume. And so this is a compilation error. If you want to avoid compilation error, what's the next step? What do we do? Cast into cuboid. You'll say, no, I know this is a cuboid, and go ahead and get the volume for me. And that's how you can get the volume. And to get the volume, yes, you'll have to do casting. So the compiler can say, okay, fine. You're asking the compiler, consider this as cuboid, and now I know there is a volume in cuboid.
So parent to child can't also
Yeah,
child to parent both.
both ways. Downcasting, and there can be a upcasting also. This is known as downcasting. Casting to a subtype. Okay.
But it should be the relation in between.
Yeah.
If no relation in between,
Then no casting. Except for cases like wrapper class. Right? Okay, fine. This is C2 dot volume and R2 dot volume. That's what we have seen. Now, let's go back and look at the definition of cuboid again. We have written the volume method as return this dot area into this dot height. Fine. When writing this code, fine, at the time when I was writing this code, when I said this dot area, what did it mean?
This dot length into this dot.
The area available to cuboid. The area which will be available to cuboid, and at that point I was thinking, yes, the one which is being inherited. Fine. Now instead of using this dot area, we have a use of keyword super also. What you could have done is, you could have said, instead of this dot area, because area is available in superclass also, I could have written it as super dot area also. That's valid. Fine. It can be written as super dot area. Oh, where can we use super? Fine. In my class definition of a subclass, fine, it can use super dot anything which is inheritable from superclass. I could have super dot set dimensions. See, you have both things available. You can either say this dot area or you can always say super dot area. Both of them would mean the same till the point you override. If I have not overridden, fine, in my class definition, this dot area is same as super dot area. This dot set dimensions is same as super dot set dimensions. You may say this, you may say super. They both mean the same. Once you have overridden, this dot area has changed. Super dot area still means the same. Fine. Keyword super can be used for specifying any member which is available in superclass. Of course, it is something which you are inheriting, okay? Only then. Fine, clear? So everything, whatever is in the superclass has two options. You can say super dot or you can say this dot. Fine, and they would mean the same. Whether I say this dot or I say super dot. Fine, here, for example, yes, we had said this dot length. I think somewhere we did mention this dot length. Or we are mentioning this dot length. It means I could have even said super dot length. Then both mean the same. They both mean the same till the point I have a, oh, it's not called overriding because that's a variable. Methods are overridden. And variable, we say we are doing shadowing. Yeah. How many instance variables for cuboid? 3. Now if someone says, let me add a int length here. Yeah, what happens? How many instance variables for cuboid? 4. You're inheriting 2 and you got 2. You declare 2 here. There is length declared in superclass. Here it is available as super dot length.
Area is also volume is also gonna be an error only,
Which one?
as area is overridden.
Area has been overridden, but we have made use of super dot area. If you say this dot area, it's going to use area according to what is written here, where it says this dot length. Now what would be this dot length? Cuboids length. What is it? What's the value? 0. It's not being initialized. In our constructor here, we have not initialized this dot length. The super length is initialized. Super width is initialized, but super width and this width is same. Super length is not same as this length because we added length here. Fine. Got the point? Okay, fine. This thing we call as, this is known as variable shadowing. Clear? Use of this and use of super. And other point was related to method binding done at runtime, but variable binding is done at compile time. Variable binding is done at compile time. Okay, so let's leave length as uninitialized, so it would be 0. We are not in initialization of length in the cuboid. Okay, we have a variable shadowing. And one more point you should know is variable shadowing is not a practice. Overriding is a practice. We do override methods, but we don't normally go for variable shadowing. Okay, fine. But another point was variable binding is done at compile time itself. Okay, so fine, with this variable binding at compile time, you got what? See, now I have got these objects created. Fine, with this new definition where length is also a instance variable for another instance variable for cuboid. Okay, fine. Now with this definition, tell me what is R1 dot length, what is R2's length, and what is C2 dot length. C2 dot length is 0. What is R2 length?
R2 7 0.
Variable binding at compile time. For variable, it will be decided by type. Compiler knows type. Compiler goes by data type. At compile time itself, it is decided which variable it is going to be using. Fine. So it's when I say R2 dot length, yes, this length is the rectangle object's length. Rectangle length according to rectangle. Length according to rectangle. Fine. Okay, let's do casting now.
So the R2 dot length
R2 7 0 or 7?
R2 dot length is
7
7. Sorry,
0 or 7?
it is 7.
7.
It is 7. It is according to rectangle. It is according to rectangle. Sorry, yeah. It is according to rectangle. R2 dot length is according to rectangle. The rectangle length according to the rectangle type. Okay, let's do casting now. So someone says, let me cast to cuboid and do something like this. R2 dot R2 is cast as rectangle, and then I am asking for length 0. Okay, let me cast into cuboid. R2, again R2 cast as cuboid, and I ask for area. Which area? I have cast it as cuboid and asking for area.
Cuboid area. Cuboid's over here.
Towards area.
Cuboid's area. Okay, let me do another one then. This is cuboid's area. That's the wrong one. We have C2 upcasting into rectangle and then asks for area. Which area?
Rectangle.
What's the object in C2?
Cuboid.
Casting and all these things is about type, which is related to compiler. Okay, fine. It's just, it can't be done. Yes, you have the object of cuboid, you are asking for area, it's according to cuboid. Methods always go by object, nothing can change it. If there is an object of cuboid, you are asking for area, there's no way you will be able to get the area according to rectangle on an object of cuboid.
Casting has no meaning.
Huh?
Casting has no meaning.
Yes, not for method invocation. Upcasting doesn't mean here when method invocation is done. Upcasting has a difference when it is a variable which you are trying to access. And for variable, yes, definitely. Fine, clear on this? Cuboid and rectangle, okay. Fine, variable and method, fine. The difference, okay, and casting, the effect of casting. For variable, yes. For method, no. Fine.
So the second one, the R2
Anyway,
rectangle area should be
R2 rectangle area, R2 is which object? Cuboid. When invoking method, it is the object.
cuboid. Both cases.
Yeah, both of them cuboid because both of them have object of cuboid. Fine. Okay. Fine. So this is about the use of supershoot. Now we clear them. Fine. Yeah. So now the next thing. What's the next thing? Okay. So fine. Inheritance from a class. This is what we have. So any questions now?
So rectangle R is equals to new cuboid. Is it polymorphic equals
Polymorphic in the sense, yes, when we do overriding, of course, you will get polymorphism. For the same, fine, depending on which object, you have a different method invocation. That's what is polymorphism.
So
When we do overriding, yeah.
if you had a class test cuboid,
Okay.
extends rectangle, then
So
declaring
another class extending rectangle, cuboid is there, which is extending rectangle.
and test
Cuboid also, that's another kind of a rectangle. Okay.
Then we declare a rectangle variables and create an object. Then which rectangle class?
And then get. You're saying test rectangle should extend from, sorry, test rectangle, test cuboid extends from
Rectangle.
rectangle. Why you want this?
If there is a case.
Here is rectangle class, okay,
Yes.
and you have a subclass, one subclass already called
Cuboid.
cuboid, okay. You want to have one more. Why do you want to call it test cuboid? Let's call it new rectangle, okay. Yeah, let's call it new rectangle. Now tell me.
We had a main method in test new rectangle.
Anywhere, main can be anywhere. I can be using hello world, put a main there, and yes, I can still be using. It's a static method. Methods are static. This main method is static, so it doesn't matter where I put it. Fine, main doesn't matter where it is. Right?
So in new rectangle we are declaring a rectangle variable.
Or in new rectangle, You want to declare a variable of type rectangle.
I'm creating the object of rectangle.
Okay.
There
As
is-
an instance variable.
Yes.
Inside this, there is an instance variable called, what's a variable name?
Variable name. A1.
Fine. This has two variables, length and width. Right? You're adding one more variable to this, and that you want as of type rectangle. Okay. So whenever you have an object of new rectangle, it would have length, width, and a rectangle object. And rectangle also, yeah. Three variables. Fine. See, as clear, when you go for subclass, the meaning is this: you're inheriting. Fine. You may write main anywhere. Main is doesn't matter. I need some place to keep my main method. It could be that hello world thing. Public static void main, rectangle, new rectangle, cuboid. They are types. Fine. Declare variable. If you create object, instance variable come into existence. Fine. See, this class thing is fine. We've seen the whole various things within a class definition which go in a class definition. Want to have a different view? Fine. Just have another view. Look at what is class. Try to relate with the real world. Fine. What's the relation between class and object? Okay. So what is a class? A class is a blueprint. Fine. For its objects. And according to which objects will be created. Right. See, if you want to create something in real world, someone wants to start manufacturing, let's say, washing machine. What does he do? Someone wants to start, okay, I want to start creating washing machines. Then what? Huh?
It has a blueprint.
He needs a blueprint first, right? He'll get a blueprint. Fine. What's there in the blueprint? Fine. There'll be something called bill of material. Fine. I don't know whether you understand what is meant by bill of material. It would mean he has a list of everything which is required for creating one washing machine. To have one washing machine, I will need so and so item. I'll need these motors. I'll need so and so screws. Each and everything will have to be detailed. Fine. That's my instance variables. This is in the blueprint. There's no actual screw or anything there, but it's all in the blueprint. It's just a definition. Class is simply a definition. It's that blueprint. Fine. Then there will be a procedure. In that blueprint, it will be mentioning how to assemble it and create one piece. The whole procedure would be there. Fine. Fine. But yes, he will do it when this procedure, then he does this procedure only when he gets some order. Someone says, okay, manufacture one object. Oh, but when I have to say manufacturer, I'll have to give some specification, some input in terms of, okay, I want to create a large size or a small size. Fine, that input has to be there. Once you give me input, then I can start assembling and creating one object. Fine, then I create a how to assemble, that's in the blueprint. Use a blueprint. So blueprint has a constructor. Fine. And then the blueprint also has more things. But one thing, once one piece has been created, fine, what does that washing machine object have now? The real object. Fine, the real world washing machine object has. It has buttons. That's how you interact with it. Fine. What the blueprint says is, if someone pressed this button, this is what should be happening behind the scene. Fine. Fine. If you put this button, okay, what will be happening, how the things should happen is all there in the blueprint. What are those buttons? Those buttons are nothing but your methods. They are the ways you will be interacting with the object. Once object is there, this is how you interact. So methods are the buttons. Fine. On your washing machine, you have your buttons, they are the methods. Fine. And then you use those methods, fine. And then ultimately, I don't need this. What do? Keep it aside? No, it's fine. I have used it sufficiently and now I don't need it. What do? Keep it aside. And then we have this garbage collector. He'll come and pick up. Fine. That scrape guy. Fine. Fine. Now, what he does? He puts the hammer. Fine. But before he puts the hammer, he has to, our machine has one special button. Fine. This button is not supposed to be used by us, the normal user, because once you press it, all warranties are void. No warranties. Okay, fine. Fine. So, but yes, before you destroy, use this button. Otherwise, there will be gases and other things which will come out. Okay. Fine. The idea is, yes, you will have to, you have something which is done by the garbage collector. He has that special, he has the right to that special button. He should be doing it in his procedure. Before he applies the hammer, take care. And so we have that finalized method. Fine. So that's how it relates to the real world objects. Fine. Methods are buttons. And instance variables, they are nothing but your bill of material. Fine. Everything which is needed for one piece. Class is simply a blueprint. Fine. When you write the main method, there you are saying, okay, I want to create this. There you start. Fine. Once you create, you have the object. Before that, it's all just a blueprint. Okay, so now, fine, we have this class cuboid and rectangle. Fine, you can try this now. Fine, I think it should not take, you should be able to finish it today itself, right? हो जाएगा ना? Fine, so you have the practice start.